everybody. Good morning.
Good morning, sir.
Okay.
Good morning, sir.
Yeah. So now I'm just touching upon this. I suppose you can see here that in a battery, inside a battery, there is chemical reaction, and in that you can see the H plus molecules here are moving in this direction. I hope you can see. Okay, are moving in this direction. So it is in the direction of conventional current. The positive charges are moving like this. The conventional current due to positive charges are in this direction. And you can see the negative charges. Chlorine ions are moving in this direction. The conventional current due to chlorine is again in this direction. Okay. Now the net conventional current, okay, is this current plus this current. It is in this direction. Clear? Okay. Now, yesterday there was a lot of discussion on this. Okay, I just convince you in a bit. If you are not convinced, then we will meet in the evening. Okay? Now you see here. In 1800, okay, first electric current was discovered. 1800. Okay. Then in 1820, magnetic field due to electric current was discovered. 1800, electric current was discovered. In 1820, magnetic field due to electric current was discovered. That is, you can see that there is a conductor. In that conductor, current is flowing in upward direction. The magnetic field is encircling that. Okay, and now you see the magnetic effect of current was discovered by Oersted in 1820. He demonstrated the effect by plotting compass so and so. During that time, 1820, electron was unknown. There was no electron current. So it was assumed that positive charges are moving in upward direction. In 1820, electron का नामो निशान नहीं था. ठीक है? बाद में in 1897, J.J. Thomson discovered electrons, and there afterwards electron current was placed. And now in 1897, after 1897, see here, after 1897, it was established that the current in the conductor is because of the flow of electrons. See, there is current flowing, but how was current flowing? So they only assumed that positive charges are moving. Actually, positive charges are not moving. But at that time, the science was not developed. So they said that there is current. But they didn't know exactly what is causing the current. Afterwards, after J.J. Thomson discovered electrons, then they understood that it is because of the electrons. And they found that electrons was moving in opposite direction of the assumed current. Electrons were moving in opposite direction of the assumed current. So, therefore, you see here, after 1970, it was established that the current in the wire responsible for the magnetic field, the current in the conductor responsible for the magnetic field, was due to the electrons moving in the opposite direction of the thumb rule. Instead of modifying the thumb rule, scientists created the concept of conventional current. Is that clear?
Yes, sir.
Hello. Aryan, are you there?
Yes, sir.
Did you understand now?
My class can repeat, sir.
After 1897, it was established that current in this wire, responsible for magnetic field, was due to the electrons moving in opposite direction. First, they assumed that current was moving in upward direction due to some positive charges. Now, after the discovery of electron, they found out that the current was due to not positive charges but electrons moving in opposite direction. Right? And now that they know electrons is moving in upward direction, the thumb rule should have been changed. But instead of changing the thumb rule, they kept the thumb rule as it is, and they started giving the name. They gave the name for the current as conventional current. That's it. Okay, that's it. No more discussion on that. Okay, so this already we have discussed yesterday. Current, and if you read this very carefully, you will understand the difference between natural current and conventional current. Okay, so you please read this. I have given very elaborate description on this, and I suppose you will understand. Okay, so yesterday I have touched upon voltmeter, ammeter, and huh? No, I will teach you. I told you I will teach you. I will teach you potential, then I will teach you voltmeter. But you should know that these are the units because I have to use these units. Okay? So this is in general about. I'm just giving you that units are there and these quantities are going to be used. Okay? And then yesterday we have discussed what is electricity. Electromagnetism is the big chapter. I will explain that in later. Okay? Right. Now we have seen different phenomena associated with electricity. And yesterday I have told you something about lightning. There are terms like induction, dielectric breakdown, electric discharge, streak of electrolyte. That I have explained in brief. Sometime later I will explain in detail for all of you. Right? At this stage, it is important that you should appreciate that all these phenomena is associated, okay, with something with a branch of physics called as electricity. So the branch of physics electricity will explain all these phenomena, why this is happening. Alright? Now electrical energy. Okay, so you know mechanical energy. Mechanical energy is, you know that it is of two forms. One is potential energy, other is kinetic energy. See, now this duster has mass, right? And there is Earth's gravitational field in the downward direction, correct? So if I leave my hand, this duster is going to fall down. Why will it fall down? Because of the attraction of Earth. Now, in order to make this duster to come here, right, what should I do? I have to pull this duster up. I have to apply force in the upward direction, then only it will come out. I have to apply force in the upward direction against the gravitational pull. I have to apply force against the gravitational force. Got it?
Yes, sir.
See, pull is a common word, force is a scientific. So, I am applying force against the gravitational force and I am making it to move. Now, here I am applying force at this point on the duster and this duster is displaced. Okay, so I have done work on the duster. What is the work done by duster? Force applied may be into displacement. And this force is opposite to the gravitational force. So what is the work done by gravitational force? Minus Fg into d. D is the displacement. Fg is acting down. Displacement is up. So if you multiply these two, you will get minus Fg into d. Now it is not Fg, it will become Fg means force due to gravity. Now force due to gravity is in downward direction. My force applied is in upward direction. Okay, so I will just differentiate. See, now this is the table. This is the duster. Now I am applying force, external force. Sorry, I am applying force in the upward direction. Which force? External force. And this duster is displaced from this point to this point. Say this point. Because I am applying force in upward direction. And this total displacement is d1. So the work done by this force is F external, okay, F external into d. Got it?
Yes, sir.
Aryan and all. I will not repeat this. Now be careful and understand at each stage. And if you don't understand, you ask in now only. Clear? Everybody be alert. So the work done by external force is F external into d. Got it?
Yes, sir.
Now at the same time there is gravitational force also acting on the duster. Got it? So work done by external force is F into d. And work done by gravitational force will be minus Fg into d. You should know what is work done, then you will understand this. Work done by gravity is, like this. Dot product and all. If you don't know, don't get it confused. Work done by gravitational force is negative on the body. Work done by is positive on the body. Okay. Now, here at this point, if you have any question, quickly ask. I will not repeat this.
Sir, then Work done of the gravity is negative due to the distance in the opposite direction, no, sir?
Yes, the displacement is in opposite direction to the force. Therefore, it is negative. Correct. Yes, yes.
The object, means the object was first on the ground.
Now it was on the ground. I have lifted it up to this point, from here to here. Clear? Is that clear? Okay, I'll proceed. Now, this work done. See, what is energy? Capacity to do work. I hope all of you know this. That means now, what is the meaning of that? If you do so much work, then so much energy has to be expended. You cannot do work without energy. You cannot do work without expending energy. There is nothing like perpetual energy. Perpetual andra without expending energy, you will do work. Understand? That's called perpetual, right? So there is no scope for perpetual work and perpetual energy. So this work is done at the expense of energy. Who is giving this energy? I have to give energy to this. So much energy is expended. How much energy? Fx into d joules of work is done. Fx into d joules of energy is expended. Got it?
Yes, sir.
Now, another concept is negative work. This is negative work. Okay? Understand this. Now,
No, the energy and work done are both equal, sir.
yes, magnitude wise they are equal. Numerically they are equal. But they are two different concepts. Hello?
Yes, sir.
Numerically they are equal. Okay? See, the meaning here is it is a rational unit. That is, you do so much, so many joules of, you expend so many joules of energy, so many joules of work is done. That is the relation between the two. But energy is a different physical quantity, work done is a different physical quantity. Your energy is converted to work. Hello, are you with me?
Yes, sir.
So in a cycle pump, or when you compress something, your energy, you will do work on the cycle pump, it will get converted to energy. So both can happen, work to energy, energy to work. Got it?
Yes, sir.
Done. Okay. So this is the work done by you and you are expending so much energy. Okay. Now here, this is the work done. What is this? This is the work done on this body by gravity and it is negative. You got it?
Yes, sir.
Now you see here, I will define something here. All of you be very careful. Okay. Now this body, you see here, this body was here. This body was here. Now it is here. This body was here. Now it is here. Now when this body is at this point, see when the body is at this point, right? Now if I leave my hand, right? If I leave my hand, what happened here? It accelerated downwards. Correct? Now supposing when it was coming down, right? It has something more than that. See, for example, if this duster is on my head, no problem. But if the duster is moving and if my head comes in between, you know what happens. So now there is a concept called kinetic energy. Energy possessed by a body by the virtue of its motion. It's called kinetic energy. Energy possessed by a body by the virtue of its motion is called kinetic energy. So now this body at this position has potential energy. When I leave my hand, when it is moving, it has got kinetic energy. So potential energy gets converted to kinetic energy. I hope this much you know. Okay, well, right. So here students, the body at this point has got potential energy. Agreed?
Yes, sir.
Then in 8th standard, 9th standard you have studied, the potential energy is M. M is what? The mass of the body. G is acceleration due to gravity. And then you have said height. So I have taken here D. If you are comfortable, I will make it H. So the potential energy of the body is mgh. Agreed?
Yes, sir.
Yes, sir.
Right. You have studied this in high school. Now, how did you get this formula? You have not studied. Hello. How did you get this formula? You have not studied. Okay, I will tell you how you got this formula. See, this one is there. Hello.
Yes, sir.
So this is the work done. Fg into d is the work done. Okay, now since you are using h, I will convert it into h. I will convert it into h. Okay. Now this work done. Okay, I will use the word negative of the work done. Negative of the work done by the conservative force. Conservative force. Negative of the work done by the conservative force, okay, is the potential energy of the body. Here, negative of the work done on the body. Negative of the work done on the body by a conservative force is the potential energy of the body. So here already the work done is minus Fg to H. Negative of minus Fg H.
What is conservative force, sir?
Wait here. Wait. See, when I stop and ask you, do you have doubt? Then only you ask. Don't stop me. I'll tell you what is conservative force. I know that I have not explained, and you are supposed to know that and come here. I know you are not. You don't know. I will explain. Now hold on. Huh? See, I was teaching something. So see here. Negative of the work done by conservative force. Gravitational force is a conservative force. Hello.
Yes, sir.
Friction is a non-conservative force. Okay.
Yes, sir.
Frictional force is non-conservative. Gravitational force is conservative. At this point, you understand so much because I have to teach electricity, not mechanics. Otherwise, I will start teaching mechanics. Okay. So I will teach you. Don't worry. You will understand. So gravitational force is conservative force. Frictional force is non-conservative force. Okay. Now, only thing is I will tell you. Okay. I hope you can understand. If you can understand, fine. Now, you see, the amount of energy I expend to bring the duster from here to here in this path. See, the path is this. Or I will bring the duster like this. Then also its potential energy is mgh. Now also its potential energy is mgh. So, in a gravitational field which is conservative, the work done is irrespective of the path chosen.
Yes, sir.
Hello, is it clear?
Yes, sir. Yes, sir.
So, whatever energy I expend to bring it here is the same energy I expend to bring it here. This is possible because gravitational field is conservative. Now, supposing now you see I will take a non-conservative. I will go for a this one. What is it? Non-conservative. See here. Now here, if I want to take the duster from here to here, I am expending some energy.
Yes.
Now here I am doing work against gravity and against friction. Now forget gravity. The work done against friction is something. Now if I bring the duster from here to here, again I am doing work against friction. Hello. But friction is not conservative. Understand? So therefore, the work done depends upon the path chosen. Hello. The work done depends upon the path chosen. That becomes non-conservative field. And non-conservative for friction becomes non-conservative force. Okay, Aryan, fine?
Yes, sir.
Done. Okay. So gravity being conservative force, the concept of potential, see, potential energy is a concept. Now understand, concept means it's an idea, right? Which is helping us to understand a phenomena or a law or a theory. Okay. So potential energy is defined as what? Negative of the work done on the body by a force, by conservative forces. So that gives you this, right? So minus of minus becomes plus. Hello?
Yes, sir.
So this becomes Fg into H. What is Fg? Gravitational force. What is gravitational force? Mg into H. Understood all of you?
Yes, sir.
So this is mechanical potential energy. क्या बोला मैंने? Because gravitational force is mechanical. Got it? Okay, done. Thank you, sir. Okay, now going by the same analogy, right? Now understand. Here you have a body of mass m, and then you have another body of mass small m, and this body is lifted from this point to this point, and this distance is h, right? Hello? And therefore its energy with respect to this point, the energy with the potential energy with respect to this point is m into what? Acceleration due to gravity. Okay. Now, right. See here. Here, I have told you that around mass. What is there around mass?
Gravitation.
Very good. Rushin is fully active. Gravitational field is there. Okay. Now, so there is gravitational field. Do you remember the diagram I showed yesterday? If this is a point mass, the gravitational field is represented like this.
Yes, sir.
What is the meaning of this arrow?
The gravitational field is stronger.
Direction of the
starts decreasing as we go.
See, you should not by heart and come to the class, man. You look at the thing that I wrote on the board. Did I write many arrows? You are telling gravitational field is more at the center left. Does this diagram say anything like that?
Specify the direction of the gravitation.
Wait a minute. Now here I am showing you vectors. I am not showing you. I am not showing you like this. I am showing you vectors. So what does these vectors around this point mass mean?
So the vectors show that the gravitation, the mass of the object, the gravitation.
No, think properly and answer. You cannot answer rubbish. You think and give me wrong answer. I agree. But don't give me answers without thinking. What does these arrows indicate? It indicates that there is a vector field. Hello?
Yes, sir.
See, that means every point in space, at every point in space. See, what does this mean? What does this representation mean? It means at each and every point here, I can place a vector. Hello, understood?
Yes, sir.
Yes, sir.
It means at each and every point in space around this mass, I can place a vector. Got it? So I have placed a vector. Okay. Now this vector, I will see. Now you know a car is moving at 10 meters per second towards east. So a car is moving, right, 10 meters per second in the east direction. I represent like this. What does this? See, I can give any symbol. E cap stands for unit vector in the east direction.
Yes, sir.
10 meters per second, car is going with so much speed in east direction. So some arbitrary direction x. Another car is moving at 20 meters per second in arbitrary direction x cap. Meters per second. I suppose you understood?
Yes, sir.
This is the vector notation. Now here, I will give the name to this vector. I have to give some name to the vector. Hello, understood? Some name to this vector. The name I am going to give to this vector is E, G, bar. Some name I see. For velocity I give V bar.
Yes, sir.
For acceleration I give A bar. Some vector generally. I will give the name EG bar. Now you will understand what is EG bar. Hold on. EG bar is a vector. Hello?
Yes, sir.
EG bar is a vector. Now EG bar I can write it as EG into R cap. Okay, what is R cap? R cap is a, see, when I say X cap, means supposing this is X direction, then unit vector in this direction becomes X. So if I multiply 20 by X cap, that means I am multiplying the magnitude by X. And I am getting from this symbol, I am able to tell that I have got a car which is moving at, don't worry, if you want to cough, you cough. Comfortably you cough, don't worry. If the car is moving at 20 meters per second in X direction. Hello, understand? So V bar is a vector. So here EG bar. What is EG bar? EG bar is EG R cap. Now R cap I have to define. What is R cap? R cap is unit vector. See here, now understand. R cap is unit vector towards the center of Earth. It means it is along the radial direction.
Yes, sir.
Towards the Earth. Got it?
Yes, sir.
What I am trying to tell you here is EG R cap means there are vectors which are all everywhere and they are all pointing towards the center of Earth.
Yes, sir.
Understood? Can you feel this?
Yes, sir.
From every direction, it is all pointing towards the Earth. Means you are getting a feeling that something is coming, moving towards Earth. Now don't ask what is moving. See, in physics, there is some things where, you have to just create that feeling. You have to create that feeling. Okay? So something is coming towards Earth. That is how you should get the feeling. So that feeling, I have shown it by these vectors. Clear?
Yes, sir.
Now EG is some magnitude. I don't know what is the magnitude. Some magnitude. Assume, correct?
Yes,
EG is some magnitude. Okay. Now you see, students, very carefully. Now here I have, what are these? These are all vectors. The name given to the vector is EG bar. If you want to drink water, you drink. It is EG bar. Okay? Now think and tell me. Now students, if I place a mass here, M. See, this is Mahamass M. Now if I place a mass M here, that is, this is big mass, here I placed a mass here. What happens to this mass? It gets attracted towards Earth. Okay, good. Now, what is happening on mass M?
The
Gravitational force is acting.
Yes.
Hello, is that clear?
Yes, sir.
How much? So the gravitational force that is acting on this is in this direction. This is gravitational force, Fg. Got it?
Yes, sir.
This is gravitational force, Fg. Got it? So this is gravitational force, Fg, that is acting. Clear?
Yes, sir.
Now see. Now Fg bar. What is Fg bar? Gravitational force acting on the mass here.
Yes, sir.
This is equal to m into Eg. What it means? See here. At this point, I have defined a vector Eg bar. Right? Right. Now, this Eg bar is representing the field, gravitational field. See, I told there is gravitational field.
Yes, sir.
Now, what is gravitational field? I told it is a region where bodies having mass will experience gravitational force. This is qualitative definition. Quantitative definition. Quantitative definition. I have to give some quantitative definition. You know that's the standard. Okay, now you see the quantitative definition here. Eg bar will be equal to Fg bar divided by E. Means what? The gravitational field at some point P is equal to the gravitational force experienced by a body of mass m per unit mass. देख अभी क्या है? At this point I will place a mass of m. It will experience force. How much force? Fg. I will divide that Fg by the mass. Then I will get some quantity. That quantity is Eg bar. Now, sir, what is the gravitational field at this point? Some other point. You measure the gravitational force at this point. At this point it is Fg1 bar. At this point it is Fg2 bar. And whatever mass I am using here divided by this mass, I will get the gravitational field intensity at this point. I will get the gravitational field vector at this point. That is what I am saying. Got it? So that means now, you see here, that means if I place a unit mass, see if m is equal to 1, क्या होगा m is equal to 1? Eg bar will be equal to Fg bar. Hello?
Yes, sir.
See now I am going to define the gravitational force, gravitational field as force experienced per unit mass. If m is equal to 1,
Yes, sir. Yes.
force experienced by unit mass. देख मैं क्या करता हूँ, पूरा ब्रह्मांड में around Earth, at every point I will place unit mass. Here also I will place unit mass, it will experience some force. Here also I will place unit mass, it will experience some force. Here also I will place unit mass, it will experience some force. Got it, all of you?
Yes.
And it will experience some force means I will get vectors at each point.
Yes.
And this vector will have magnitude and direction.
Yes, sir.
So everywhere I can, now you can see, I will place one mass here and I will ask, hey uncle, you what is the field there? Note down. Okay, Rajdeep, I will place unit mass here. What is the field? You note down. So everywhere I will place. Imagine. So you will get vectors everywhere. Those are the vectors. So the gravitational field is represented by the gravitational field vectors. Okay, clear? You have any question here? You ask. I will
What
explain.
is just EG, sir? Not EG, but EG.
EG is the magnitude of the gravitational field at that point. See, now, see here. Now, here. Now, see here. This is the mass of Earth. Okay. This is the mass of Earth. Right? And this is at a distance r. The distance from here to here is r. And I am placing a mass m here. Correct?
Yes, sir.
Now, what is the gravitational force at this point? Gravitational force at this point is towards this. I told it is Fg bar. Hello?
Yes, sir.
Now, how much is Fg bar? Okay, if you have studied universal law of gravitation in 9th standard, you will know that it is G m by r cap. You are not studied r cap and all. You would have only studied gravitational forces G m by this one. Got it?
Yes, sir.
Now here, here you see this. So this Fg bar means it is force, and r cap stands for what? It is in the direction towards the center. Now, if you don't want, for time being, you can simply write it. Fg is equal to G mm by r square. Got it?
Yes, sir.
Hello? Now here you see this Fg, what is Fg? Force on mass m. Hello, are you with me? If I divide it by m, that is this m, I will bring it here.
Yes,
This m, I will bring it here. Got it? Then this one is what? Gm by r. Got it?
Yes, sir.
Hello?
Yes, sir.
And this is Eg.
That GM is GM.
No, wait. First study that. That is Eg. Got it?
You can repeat this, sir.
Why do you do like this, man? I'm talking so slowly.
I was not able to understand this.
What you didn't understand?
This is like a Fg by m, why do we take?
Why did we take means I did mathematical manipulation here. I mathematically manipulated. Then see, when I did this, what were you doing? I took this m this side. Fg by m, man. I brought this m from right side to left side.
Yes, sir.
ನೀನು ಹಿಂಗೆ ಟ್ಯೂಬ್ಲೈಟ್ ತರ ಆಡಿದ್ರೆ ದೇವ್ರ ಹೆಲ್ಪ್ ಮಾಡ್ಕೊಂಡು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ Fg by m. That's what I did. Got it?
Yes, sir.
Then what is remaining on right hand side? Gm by r square.
Yes, sir.
Then I wrote that Gm by r square as Eg. And you remember here also I wrote the same thing. Hello?
Yes, sir.
There also I wrote the same thing. Got it?
Yes,
Yes, sir.
Now you see what is Eg. Eg depends upon what? Universal gravitational constant and the mass of Earth,
Yes, sir.
and it depends upon the distance. So further you go, R increases, the value of Eg starts decreasing. Got it?
Yes, sir.
All of you understood?
Yes, sir.
So therefore the intensity goes on decreasing. So if you see that arrows, the arrows go on becoming smaller and smaller in size. Intensity arrows go on become smaller in size as you go away from Earth. I suppose all of you remember this.
Yes, sir.
Hello? Got it?
Yes, sir.
Now This is easy. You asked what is easy, I told you what is easy. Clear?
Yes, sir.
Anything else? Anybody?
This empty bar is equal to mass into gravitational field bar. That is a easy bar. What it all is like a formula to find the gravitational field. As a gravitational force.
It is not, see man, don't, see I am teaching you such high level physics. So you are converting it into some, chiller formula. What is this? Why you want to do like that? The formula for EG is this. Okay, don't make it look otherwise this. Okay, formula for EG, see why I wrote the formula here? Because Sankalp asked, sir, what is EG? So what is EG he asked, therefore I told what is EG. Got it? The formula for that is that. Okay, still what is your doubt, Mr. Aryan?
No, sir, like how that gravitational field and gravitational field bar and gravitational force is related, like you get that formula.
I
What
wrote,
did we get that?
yes, I wrote this. See, now I defined it like this. See, definition is my purview. Hello? See, I defined it like this. See, your name is defined by your parents. Like that, I have defined the gravitational force is equal to m times the electric field at that point. Got it?
Gravitation.
The gravitational force on body of mass m is m times the gravitational field at that point. I defined like that, and then I have done the remaining things. Okay? Hello?
Yes, sir.
Yes, sir.
You have to be very attentive. I am telling you. Right. So this is EG. Now you understood there is EG. Hello?
Yes, sir.
Yes, sir.
Okay. Thank you so much. Okay. So now you see, as you keep taking this body away and away from Earth, its potential energy goes on increasing. Hello? Are you with me?
Yes, sir.
Because you are doing work to move it up against the gravitational force. Okay? Got it?
Yes, sir.
Got it now?
Yes, sir.
Okay, so this body has got, see now if the distance is r from this point, then this body has got potential energy mgh, sorry, mgr. Got it?
Yes, sir. Yes, sir.
Got it over here? So what is mgr? Now here, what is mgr? Potential energy. Potential energy of mass m. Got it?
Yes, sir.
Now I will do one thing now. Aram se listen, Aryan, especially you. So
Yes, sir.
now this potential energy, right side, I will divide it by m. What will I be left with? Gr.
Yeah.
Got it? What is this?
Yes, sir.
Potential energy per unit mass. Hello, are you with me?
Yes, sir.
Yes, sir.
This potential energy per unit mass, I will simply call it as potential at that point. Which point? This point. The potential at that point is potential energy per unit mass. See, instead of keeping mass of body of mass m, I am keeping unit mass. Then what is the potential is unit mass? Whatever is the potential energy for mass m divided by m, and that will simply be equal to acceleration due to gravity into the distance from us. Hello, are you with me?
Yes, sir.
Here any confusion?
So,
Yes.
so like as we go further in the gravitational field, the magnitude of gravitational force decreases. So from a point like from a point the potential energies would start decreasing also from lifting.
Good.
Yes.
Good. So here this G, what is this G?
Acceleration due to gravity.
Near the surface of Earth.
Yes, sir.
Okay. Actually, you see, okay. Now, let me come to this. Now, this is one way of to look at it. Hello. Now, he has asked a very nice question. Okay, only he has understood the question. Nobody has understood, I am sure. Okay. But first, I will satisfy him. Then you see whether you understand. Okay. His question is very interesting. We'll come back to his question. Before we come back to his question, I will answer his question first. First, let me satisfy this one. Then I will come to this. Okay? Now, what is this, gentlemen? What is this?
Gravitational field.
No. See, I didn't ask. I didn't go to the right. I have only marked here. What is this? What is this? You tell. Fg by m.
Gravitational force per
unit mass. Correct now?
Yes,
Hello.
sir.
Now let us come to Newton's law. In Newton's law, we said F. In Newton's law, we said F is equal to m into A. Hello, do you remember?
Yes, sir.
And A is equal to F by m.
Yes.
Hello.
Yes.
A is equal to F by m. I suppose you do.
Yes.
Then what is Fg by m? See, this is F by m. Here instead of F, I have got
Acceleration.
this is nothing but acceleration due to gravity. Got it? Okay. Understood now?
Yes,
Now, see, life ali aram se. Now you are a son to your father, you are a brother to your sister, right? So your behavior will be different in front of your sister, in front of your father. Correct? No? So when you are when your father is there, you have to behave like a son. When your sister is there, you have to behave like a brother. Correct? No? Now forget this. Whatever I have done here, this is for in one context. I wanted to explain gravitational field, so I have done the manipulation. Now I will be dealing with another context. Now Aryan, don't generalize. Thankfully, don't generalize. Now here you see Fg by m is acceleration due to gravity. Okay. Now the formula for acceleration due to gravity is also gm by r. But then now you say, oh, then acceleration due to gravity is electric field. No, don't conclude like that. Ada ಬೇರೆ ಇದ ಬೇರೆ ತಿಳಿತಲ್ಲ ಎರಡರದು ಫಾರ್ಮುಲಾ ಸೇಮ್ ಆದ್ರೂ ಅದು ಬೇರೆ ನೀನ್ ಸೇಮ್ ಇದ್ರೂನು ನಿಮ್ಮ ಅಪ್ಪಾರಿಗೆ ನಿನ್ನ ಮಗನ ನಿನ್ನ ತಂಗಿಗೆ ನೀನು ಅಣ್ಣನ ತಿಳಿತಲ್ಲ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ suppose you will not have confusion. Formula is same, son is same, the person is same, but here he is son, here he is brother. Got it?
Yes.
Okay. Gm by r square. Now you see here, acceleration due to gravity, how much is the value I told? 9.8 meters per second. This is very much close to the surface of Earth. As you go away from Earth, this acceleration due to gravity will start decreasing. Got it? And if you go very far off, it becomes zero. It becomes very less, negligibly small. So the gravitational potential is G into R. So if R is increasing, G is decreasing. And here you see it is R square. That means the acceleration due to gravity will decrease exponentially down. R will linearly decrease down. So the potential at a point will go on decreasing as you go away from Earth. Your question is clear now? Yes. Good. Did everybody else also understand what I told?
Yes, sir.
Okay. This is because of this. Because G is not constant. Now all of you understand. Now as far as solving problems in 8th standard, 9th standard, 10th standard is concerned, you are dealing with all the objects falling near the surface of Earth. Say about 50 to 100 kilometers, less than that. You always solve a 10 meters, 20 meters, a tall building 20 meters high, only that much. So for all practical purpose, you can treat the acceleration due to gravity as constant. For practical purpose, actually it is not. Now if I make it, if your first 8th standard book, acceleration due to gravity is not constant. You remember, students? And now if the equations are introduced, then you will not learn physics at all. Because the basic formulas that we have used in physics, okay, what are the basic formulas? V is equal to, okay, U minus GT. You remember all these formulas? V square minus U square is equal to 2AS and all. Here G was considered to be constant, and that's why you jolly well solve the problem. First year PUC, when you come to first year PUC, you cannot use this equation unless they told it is acceleration due to gravity is constant. And you are going to deal with problems where acceleration is not constant. Understood? So you have to now consider the reality that as you are lifting the body, the acceleration due to gravity is changing. So now potential energy will not be mgh. Hello? Understand? It will be integration. You have to use the integration and you should do it. And that is what will be taught to you in first year PUC. So in 8th, 9th, 10th, if you have understood this formula, then in first PUC, this formula will be redefined using integration. Okay? And they'll redefine using integration and you have to solve it. Right? So life is going to be different. So therefore, know this and come this.
Even at such small distances, the acceleration due to gravity changes.
Small, it changes in very small amount. See now here, if you see now Earth's radius of Earth is 6,400 kilometers or 6,400 into 1000 or 64 into 10 to the power of 5. This is meters. This is the radius of Earth. Okay? Now, see, acceleration due to gravity G is equal to G M by, see now Earth, you are keeping a body here. Hello? Hello? This distance is R. This distance I will take it as H. So this distance R will be what? So this radius is R. So this distance, the distance from here to here I have taken it is R. So R will be equal to what? R plus H. Agreed?
Yes.
So here I'll write it as G divided by R plus H whole square. Hello, understood?
Yes.
Now here what happens if I have to manipulate this? Now see here, this R is 64 into 10 to the power of 5 meters. And say you are keeping a body at what point from Earth?
5 meters.
5 meters. So Sankalp wants to keep it at 5 meters. 5 meters. So how much will you get the value here? 64. See, this denominator will be what? Denominator will be 64 followed by 5 zeros plus 5. Okay. See, if you divide this number by this number, which number? If you divide this number by 64 5 zeros, you will get some number. GM divided by 64. Hello?
Yes, sir.
Now the same number you divide it by 64,0,005. What will be the difference?
Slight.
Very slight. 0.0000 at some point. Got it?
Yes.
ಈಗ ನೀವು weighing machine ಮೇಲೆ ನಿಂತಿ. Okay, you are standing on the weighing machine, right? And supposing somebody keeps a small dust particle on your head. Listen, you are standing on a weighing machine, it is showing your weight. Somebody keeps a small speck of dust particle on your head. What happens? Will your weight change?
Yes.
Hello?
Yes.
Or will you start crying, "Hey, you kept a dust on my head, my weight increased. So from intermediate now I have to participate with seniors." Will you shout like that? Hello? So, but theoretically your weight has increased. But that is not significant. ಈಗ ನೀವು ಊಟ ಮಾಡ್ತೀವಿ, ಒಂದು ಅಗಳು ಕಡಿಮೆ ಆಯ್ತು, ಹೊಯ್ಕೋತಿ. You will not shout no? Understood no? It is insignificant. So same way, the G will change, but it is very insignificant. So for all practical purpose, even up to 100 kilometers, you can treat it, G is constant and solve the problems. Then only you can use this linear equations. Otherwise, you cannot use the linear equations. Life, they make it simple. Because some physics, see, studying physics is like this. You have to start somewhere and you study some elementary physics. Some little of mechanics, little of electricity, little of magnetism, little of you study. So you will get some understanding. And then after studying this first level, then you will once again study more of this. Again you are going to study electricity, magnetism, that, this and all same things you'll study, but at higher level. And again, when you go to BSc, you will study still higher, and MSc you will study higher. Understood? So you will study something. So at the first level, you are studying that acceleration due to gravity is constant. At the second level, you will study that acceleration due to gravity is not constant. At the third level, even Newtonian mechanics you will not use. You will use special theory of relativity and study again gravity. So this whatever you have studied now is elementary. This is foundation for what you are going to learn in the higher classes. This is not the ultimate thing, but this is the stepping stone for your future. Keep that in mind. That is why you should study these fundas very strongly. Yesterday, TV report showed very clearly. Okay, in all the big companies, Google, etc., everywhere. Okay, the top executives. See, if you find Google and all these places, no, majority of the people who are working are Asians, especially Indians. Nearly 60 to 70% of the employees are Asians, and of them nearly 50% is Indians. But if you look at the executive level, that is the top cream, the top level. See, you will be in the, say, 8th level. So there is top 7th, 6th, 5th, 4th, first level. In the top executive level, hardly there is any Indian or any Asian. Understand? You understand, all of you? So you all are wonderful students. You will get good marks in school, 90% and all. You are smart. See, anybody interviews you, they will find that you are a good student, you are a learner, you are a workaholic. So they will employ you, they will keep you at the lowest level, and they will keep patting you. But you had the potential to rise to the highest level. You had the potential to start your own company. They will show some XYZ Pichai and some few people, oh, Indians are great. How many? If you go and check the statistics, it hardly contributes only 5 to 6% are at the executive level. Rest of them are at the lowest level, and some people call them as white collar coolies. 5,000 rupees per day, salary per month. Okay, there you get $5,000. Here 2 rupees one copy, there $2 one copy. You convert, you go there, earn $5,000 and come to India. Then it becomes what? 50 into 8, 4 lakh rupees. So your salary is 4 lakh rupees as far as India is concerned. 4 lakh rupees in India is a fantastic money, salary. But 4 lakh rupees in convert to dollars in America, you are just an ordinary person. You will stay in a small apartment. You are leading a very ordinary life there. But when you come to India, everybody says you are American return. What are you doing there? You are doing some very menial work. And after some 5-10 years, you will understand that you are good for nothing. So you have to slog under that fellow. That fellow will say, you better do this work. No, sir, what is this? You told you will give promotion. I will not give promotion. You want to leave? You leave. Others get out. You will go. Or he will only send you. But you could have come to highest level. If you learn science properly like this, you will become executives. If you simply superficially learn and by heart, you will go to US, Australia and all. No doubt, because that is your dream. You don't want to stay in this country. That is your dream. But you will find that after the age of 40, you will be miserable. Because you will understand that you had higher potential. Put your head down and work. India only, you have got so many startups. You can build your own industry. You can become a crorepati and live very happily in our country. Why you want to go and stop? You understand? See, once upon a time, I have enjoyed all the rich. This big house, servant quarters, 2 cars, driver, 40 people working under me, 2 colleges I built. All in Hubli. Hubli again, you with zero investment. When I came here to when I built this house, I had 50 lakhs loan. Understand? Borrowed money only I did. Okay, I had no money. But things are like that. Now you see Binda cycle. I am not very great. You can become much greater, I am telling you. But life is like this. You have to take challenge and live kingly life. You know, yaar boss adara. Nag yen bekna madu. Boss adara bera. Okay, that apart, everything is like this. Nagbada, Nindu Mund Hanebara. Okay, bye. Thank you so much. Great.